Okay, you can read those numbers, right? Those just stand for numbers. That's what it's going to look like, right?
Fairly accurate about what it's going to look like.
Huh?
Fairly accurate about what it's going to look like.
Yeah. Yeah, you're going to have numbers there where I got these bizarre symbols, you know. Whatever this thing is, a backward Greek delta with a pig's tail on it, whatever.
First time looking at it, it's going to look just like that.
Huh?
First time looking at it, it's going to look just like that.
Yeah, maybe. No, you can do the numbers. Okay?
Got to let your eyes adjust.
Reduced. For the asterisks are just different numbers, whatever numbers you end up with, right? So reduced to upper triangular form, it looks like this. Completely reduced. You get this, and those are your values of x, y, and z. Okay? Unless it doesn't look like that, because it could end up looking like this. And this is what it'll look like if one of the equations is a sum of multiples of the others. Okay? We call that a linear combination of the others. You know, linear combination is just some multiple of this, plus some multiple of this, plus some multiple of this. However many things you're combining, you just add multiples of them. And that's what we do with vectors, and that's basic linear algebra, as you see. Okay? It could happen that in eliminating the x here, you also eliminate the y. It leaves you a z, and still leaves you that row of zeros. So, this looks a lot like this looks a lot like this, except that instead of 0 here, you got something that isn't 0. And instead of 0 here, you got something that isn't 0. Now, if you got something in there that isn't 0, then what's your last equation? What would 0, 0, 0 star translate to?
Wrong.
Huh?
Inaccurate.
It's no longer an equation.
What?
It indicates that there's no solutions to that system.
Why?
Because 0 is not equal to a number.
Okay, so your left-hand side would be 0x plus 0y plus 0z equals something that isn't 0. And since 0x plus 0y plus 0z is 0, okay? Now, your immediate answer to that, the really reliable answer you can give me that shows you know what you're saying is, I get you 0x plus 0y plus 0z equals something that isn't 0. That's literally what the equation says, right? Okay? So that would be the answer that makes me sure that you know what you mean. Okay? And then you could say, so 0 equals something that isn't 0. So there's no solution. Okay? So my zeros are starting to look like deltas, but so I can write that. This means this, which is untrue, so there's no solution. Now that's a proof. Saying there's no solution, which is absolutely correct, is an assertion unless there's a proof. So you got to be literal step by step when you prove things. And we'll be talking about proofs probably next time. Okay? But this whole reduction scheme tells us things. Geometrically, either of these, any of these, tells us that two of the planes are parallel. Okay? Having a non-zero here means that the third is parallel to one of the first two. Okay, if it was parallel to both of the first two, you'd have a row of zeros here as well. Okay? And having a non-zero here says it's parallel, but it doesn't coincide. So there's a geometric interpretation that comes out of this. It's not too hard to understand. That's why I'm talking about it here in the second day of class. Okay? Okay, so one of the big stumbling blocks we always have in this course is that 3 weeks into the semester, people still can't do the reduction process. And, you know, almost no way. The 3 weeks into the course, you can't do the reduction process. Number one, that you have the combination of aptitude and work skills to learn something as, you know, it's not totally trivial, but it's pretty simple, especially with little practice, okay? And doesn't have the basis for understanding what's been said for the last 2 weeks, and is therefore dead in the water in the course, okay? So you want to make sure you're on top of this, okay? I'll give you some things to row reduce. I'll make up some with easy numbers. so you don't have to deal with terrible fractions. I just want you to get used to the process. But be aware that the fractions happen, okay? And if you're a little sharper than I am, you can do when you're happy, okay? But not something you want to worry about. Your calculators will do it, computers will do it, any computer algebra system will do it, any graphing calculator will do it. So when you get up to a 10 by 10 matrix and need to reduce it, you don't have to do it by hand. You have to do it by hand now, so you understand what's being done, and so that you think about what it means. And right now, in terms of just planes and stuff, and you don't have equations of planes in 3 dimensions. I'll give you some stuff with just 2 dimensions, 2 equations to reduce. That's real easy. You just get a 1, 0, 0, 1, or you try to get a 1, 0, 0, 1, and then whatever numbers come out. And maybe you get a 1, 0 with a number and a 0, 0, either with a 0 or with a star. You can interpret that in terms of the straight lines, and I'll have you do that. I'm not going to ask you to graph things in 3 dimensions, or even to necessarily visualize them in 3 dimensions. Okay? Okay, so that's kind of where we are. Get that down, and I put the ISBN of the book, and let me talk about that for a minute.